is ready. Okay. We want you to be ready and be with us too.
Okay, my dear participants, we are going to be hearing from Professor Hiroaki Ogata. Professor Ogata is an academic at the Academic Center for Computing and Media Studies, Kyoto University in Japan. He is going to give his talk on AI and learning analytics for smart learning environments in Japan. So it will be Japanese secret.
Yes, for sure.
Wow.
So now we have in the morning already listened to the talk about China, right? What happened in China, and already now we need to learn what is going on in Japan. So join me to welcome Professor Hiroaki Ogata, please.
Please, Sensei, thank you.
All right, let me in the meantime introduce Professor Hiroaki Ogata. Hiroaki Ogata is a full professor at the Academic Center for Computing and Media Studies, Kyoto University in Japan. He's also a director of the Evidence-Driven Education Research Council and associate member of Science Council of Japan. His research, of course, is very interesting, including computer-supported ubiquitous and mobile learning and learning analytics and very many more. I think it's now the time for Professor Hiroaki's talk.
Thank you. Thank you very much for the kind introduction. Yeah. Hello, everyone. I'm great honored to give a talk in this conference, and also I'm very happy to be here. Okay. All right. So actually, this is my third time to visit Thailand. Yeah. First time I went to Chiang Mai and ride an elephant and across the river, yeah. And then next time also Chiang Mai, and then go to massage and yeah, enjoyed. Yeah, and this time is the visit Bangkok. Okay. So my talk is about the how was the education in Japan during the COVID-19, yeah. So we had many problems, and yeah. And then I'm going to propose some framework. We call it LEAF, Learning Evidence and Analytics Framework. And then I will talk about how the LEAF system has been used in classroom and nationwide and also international wide. Yeah. So as you know, there are many schools couldn't provide education during the COVID-19. How about in Japan? We had in K-12, there was no classroom in April and May, and only 5% of school just provided online course, yeah. And in higher education, 90% universities offered online courses. So it's, I mean, in terms of the K-12 schools, the education was totally stopped. Yeah, but we could provide online course, but in online course, yeah, you know, the teachers cannot see students in remote. Yeah. That's a big problem. Even in the face-to-face classroom, it's difficult for teachers to know the all student situations. So sometimes each student has different interests, and also some students couldn't understand different topic. Yeah. So if we can collect that the data from the student, and then we can analyze that, and then we can give the some personalized quiz or some additional learning materials after the classroom. So, yeah. So then learning analytics can help the teachers to do some personalized learning, provide personalized learning environment. Yeah. So here is the framework which we propose, and actually this framework consists of the 4 elements. One is the learning management system, LMS, and then we developed the ebook reader. We call it Bookroll. So this system provides the learning log about how the students and the teachers are reading the learning materials. Yeah. So if you use just LMS system, then you cannot see how the students are learning. You can only find the student whether student download the learning material or not, only by using LMS. But by using Bookroll, you can see how long students take to read each page or something like that. Yeah. And then all the learning records can be stored in the learning record stores, and then we developed that dashboard to analyze the data in learning record stores. And we assume that each school has this component, leaf component, and then all the learning record can be managed in each schools or each company which provide a teaching learning service. And then the problem is how we can connect all the learning records. Yeah, we use the blockchain to connect the distributed learning record. I will talk about this one a little bit later. And then we can extract the evidence from the all the learning record, the data. Yeah. So about Bookroll, here is the interface. So Bookroll is the web-based system to read learning materials. So teacher uploads learning materials in PDF format and to the Bookroll, and then students read the contents using their web browser. So the student can use the smartphones or tablet or personal computers to read it. And then the 15 actions, like go to next page or go back to the previous page, or create the memos or create some markers, underlines, and yeah, all the actions can be recorded in learning record stores, and then we develop. Yeah, here's the example of the learning log data, and then we develop the dashboard. We call it log palette. This system shows the many graph for the analyzing the learning record data. So for example, this one is the, this shows the time for each page. Yeah. And so I will talk about how our system LEAF are being used in the classroom and also in other schools and also other universities in other countries. Yeah. So about classroom, the book roll is now used in classroom for language learning and also the mathematics and also for collaborative learning. Yeah. So, for example, in an English classroom, the teacher asks the student to create some underlines, like there are two types of the markers. The yellow marker means the student couldn't understand, and red marker means the student think about its important keyword, and then this shows all the student markers in a textbook to know what students don't know. Yeah, the teachers sometimes couldn't understand what students don't know, and then this shows darker yellow markers shows the most student difficult keyword. Yeah, and then in the classroom, a teacher checked this information in a dashboard just before starting the classroom, and then in the classroom, teacher explain about this unknown keyword. Yeah, so before using this kind of the information, the teachers explain based on their experience or some intuitive feelings or something like that. But this data shows what students don't know exactly. Yeah, then for teachers it's easy to understand. Yeah, student information. Yeah. And also, and also this information can be used in for the publishers to revise their textbook. Yeah. And also we use the learning log data to support the reading process. Yeah. So for paper book, there are a lot of the active reading strategies were proposed in the research area. And so, for example, SQ3R, active reading strategies, is proposed. So this is the SQR consists of the 5 stages. Yeah, one is the survey, and then question, and then read, and recite, and review. We applied this one to ebook. So we propose 2 SQ3R active reading strategies for ebook. Yeah. So first, students need to scan and skim and write a question, and then read, and then reply the questions and reflection. So through this kind of the reading process, the teachers, student understand the content in detail. So this table shows the connections between the reading process and the actions in book roll. In a scanning phase, the student use letter marker to find important topic. So this scanning phase, schema and question phase, is the should be done by very quickly to understand the overview of whole contents. And but during this short time period, the student used some tools to record all the reading process. So, for example, the scanning phase, the student use red markers, and then skim phase, student use yellow markers to mark the unknown keywords, and then student write questions in the memos, and then student read contents, and then find answers, and then reply to the answers in the memos, and then student make a reflection. Okay, so we are also applying this 2SQ3R active reading in junior high and high schools. Sorry. Yes, and so the first, the teacher needs to explain about the 2SQ3R, and then scan and skim and question in a short period, and then read the contents carefully, and then reply to the questions, and then make a reflection. And reflection phase, the student create group based on the their markers or memos. So we provide the dashboard to enhance the discussions in a group to understand more about the book. Content. Okay, so here is the another research project about the extensive reading. So we provide more than 500 ebooks, English ebooks in book roll, and then we ask students to read as many as possible. But for some of the students, it's difficult to keep reading. So, we thought it's important to support, to develop the self-direction skills by using data. So we propose a data model to develop the self-direction skill. So first, the student needs to collect data and then analyze the data and to find, to create plans. And then student create their personal plan, and then monitoring the execution process, and then make a reflection. So, for example, the student create a plan about the student read more than 20, read ebook more than 20 minutes every day. And then in a graph, this shows how long student actually read ebook every day. Yeah. So then student can understand whether a student could complete the plan or not. Yeah. And then sometimes student needs to adjust or change their plan. Yeah. And then in the reflection phase, students check whether the plan was okay or not. Yeah. So so here is the comparison between two groups. One is the blue one is the blue one is the without system, so red one is the with system. Yeah. So by using our system, the total reading time increased, and also the word per minute for each student also increased more than 33%. Yeah. And also this graph shows the comparison between without plan or short-term plan or long-term plan. Long-term plan means the plan for one month or for 1 year. Yeah. So the group which has both short-term and long-term plan increase the performance rather than other groups. Yeah. So it's important. This means it's important to create the not only short-term plan but also long-term plan. Yeah. So we thought this kind of the skill is very important to to develop in a school. So this self-direction skill is also important skill for lifelong learning. Yeah, to create the future plan, and then we may create more short-term plan. Yeah. So if we could accumulate some data, for example, in the MOOCs, maybe you can store your learning log in the MOOCs, and then the system shows how long you access to the MOOCs to run, and then you can see whether your plan is completed or not. Yeah. So okay, so here is another example in a mathematics classroom. In a mathematics course, in a classroom, yeah, the teachers provide some the questions to the booklet, and then the student write answers in a tablet by using pen. So all the writing process is recorded, and then we analyze the time to stop writing. Yeah. So sometimes the students stop writing to think, to answer the questions. Yeah. So red stroke means it took a longer time to writing. Yeah. So this means this is the we call it, this is the stuck point for the student. Yeah. So the system automatically clustering the all the student answers according to their stuck point. Yeah. And then the teacher explained about the some representative answers of the out of all the student answers. Yeah. So by using this kind of the digital, I mean, exercise and classroom, and yeah, the teacher can explain their student stuck point and also student answers very quickly in the classroom. But if they use the paper, it's difficult for teachers to find the good answers or bad answers, and yeah, it takes time. And then all the exercise is linked to each knowledge item in the mathematics. So this shows the structure of the knowledge structure of the mathematics, and then the green line shows the student comprehension level of each knowledge item, yeah, in mathematics. All right. So this is kind of the student model for the system, and then the system can recommend some quiz to the student. Yeah, but usually AI recommendation tools are just providing the quiz to the student, and so then students think, why do I need to answer this question? Yeah. So that's why this system provides some explanation, the reason to answer the question. Yeah. So in the education, there are two black box. One is the AI, of course. Sometimes the AI just provides information, but without any reason. But we think it's important to provide the reason to the student. Yeah. And then also student thinking process is also black box. We don't know how the student are thinking. Yeah. So so we use the self-explanation data to understand the student thinking process. Yeah. So in this case, the first student write answers, and then we ask student to write the some self-explanation in a system, and then analyze the answers and the self-explanation. Okay. So So currently we are developing explainable AI system for quiz recommendation. So first the student answers, solve the questions, and then, yeah, as I said here, then input some self-explanation, and then analyze the data, and then find a difficulty point or stuck point for the student, and then recommend quiz with explanation. So here is the answers. Okay, so here is the answers, and also the right hand side is the self-explanations. So the answers and also self-explanations are synchronized. Yeah, like this. Yeah. Sometimes, yeah, students use the erase their answers, but all the writing process is recorded, and then student needs to input the why student answer this like this. Yeah. Okay. And then we can analyze the self-explanation, and then, yeah, then the system can provide some reasons to explain, reasons for recommend quiz, next quiz, yeah. Okay. All right. So here is another example to use the learning load data to support the group learning in a classroom. Yeah. So, okay. So in a classroom, it takes a lot of time for teachers to create a group sometimes. Yeah. We interview the teachers, and the teachers told us it takes the 1 hour or 2 hours to create a group in the class before starting the classroom to create a group. Yeah. So because we have the data of about all the learning process, and then we can create the groups automatically. Yeah. But the teacher needs to input some the parameters to create a group. For example, the what kind of reading log data the teacher going to use, something like that. Yeah, we use the book load data, and also previous or past group learning scores, also some exam scores. Also, the teacher needs to input the group size. Yeah. And then here is the result of the group formation. Yeah. So after create group, the teacher also can modify the group member, exchange group members. Yeah, according to his or her opinion. Okay. So, okay. So we have, there are three strategies to who create a group. One is the homogeneous group, and another is the heterogeneous group, and the third one is the random group. So random group formation can be used for in the early stage of the data. So when we don't have any data, and then we can create group randomly. So also the homogeneous data is homogeneous group formation can be used to to make discussion more deeply, yeah. And also heterogeneous group formation can be used to support the this local teaching in a group, yeah. So heterogeneous group means each group member has different interests or different knowledge, and then they can teach each other, yeah. And so, okay, I skip. And in a national level, so we have this kind of the schools in Japan, and the problem is how to collect all the data in whole nationwide, yeah. So I'm a member of the Science Council of Japan, and then I established the educational data subcommittee for to use the educational data in whole country. So first we need to define the types of the educational data, and how we can use the data, yeah. And also we need to establish the ecosystem to to collect all the data from the elementary school to the universities, yeah. So also we need to build up the our infrastructure for to collect and analyze the data. Also, we need to nurture the stakeholders like teachers and the students and parents and researchers. Yeah. So, okay, so during the COVID-19, the Japanese government distributed one laptop computer for one student. And then by using this kind of the facilities, we can collect all the data. But now we are discussing about how we can collect data and use it. So our leaf system is one of the model for this, yeah. So we can collect all the data in not only inside classroom but also outside classroom, and then we use the AI or data science technologies to analyze the data and then give the feedback and interventions. Yeah. So here is the system configuration to analyze, to collect all the data. Now discussing. Okay. And then, okay, so how to collect the data in different systems. So each school use different system, I mean, like LMS or ebooks or something like that. And then the question is how to collect and connect all kinds of data. And also how we can extract and share the data and evidence is also important the research topic, and also how to make policy for the data utilization is also important topic for discussion. So currently we are now doing research on the blockchain to connect the learning logs stored in different institutions. Yeah. So we assume that each LMS or the system stored the learning log data in learning record stores, and then we can ask the teachers or the system administrators to add our board system to connect all the learning record stores data. Yeah. So it's difficult to explain, but you can read our papers for details. Okay. And all right. So also we can extract some evidence from the data. So usually in a medical domain, the evidence is collected. Evidence can be found in RCT method, but in education it's difficult to do. I mean, some randomized control testing, trials, and so I think so. Without the RCT, we can how we can extract the evidence. That's important research topic. Yes, yeah. Okay. So we propose the system called REAL. It's a real-time evidence analytics library to extract the evidence from the learning record stores by comparing the data without any RCTs. Yeah. So that's important. Okay, so currently the LEAF system is now being installed being used in various subjects and schools. Yeah, for example, in the music or in English and literature, and something like that. So we got some comment from the teachers. Yeah. So teachers changed the course design through the understanding how the students are learned outside classroom. Yeah. And also it's easy for teachers can understand the students' thinking process by visualizing this kind of the student data. Yeah. So in in the international level, yeah, education is borderless. Yes. So currently we are exchanging a lot of the students and the researchers across the countries, and then it's better to increase support, enhance the education in worldwide. Yeah, it's important. And then we asked some universities and institutes to use a RIF system. Yeah, not only inside Japan but also in other countries. For example, in Taiwan, more than 30 universities are using RIF system, and also in India, more than 65 universities are using our system. So we are now sharing experience, learning experience, and also the data and evidence, and also we are publishing the paper together. Yeah. So to deploy our system, we established this evidence-driven education research council. So what we want to do is we want to connect the research and also practice and the policies, through deploying this kind of the system. So we have organizing some workshops in Japan and also in Taiwan. So we had a book roll partnership and in Taiwan, and we had many workshops. Yeah. So sometimes the researchers in Taiwan visit our lab and then discuss about the writing the paper. Yeah. And also there is a book roll community in Hong Kong. Yeah. And also in India also we had many workshops. So in a conclusion, so what we should promote enhance the education after COVID-19. So I think we should provide some infrastructure to record and analyze the teaching and learning process for data-driven education, and also support learning for all. Also, we need to foster self-directed learning skills. Also, it's important to enhance the interpersonal communication and the social learning. Also, it's important, to share the data and evidence. Not only inside classroom, but also across schools and the countries. So to do so, we need to connect the researchers and practitioners and also the policymakers. Okay, so this is just announcement. Oh, sorry. Okay, so here is the our lab members, and also I wrote this book. So if you want to know more about the our system, and then you can read it. And so this is just an announcement. So we are organized the ICCE conference in Japan in December this year. So if you are interested in come to Japan, please just join it. And also LAC conference will be held in Kyoto next year in March. In March, you can see sakura in Kyoto. Yeah, it's beautiful. Thank you very much.
Thank you very much, Professor Hiroaki Ogata, for the very interesting keynote session, and also on the possibility to join you in future events as well. Regarding this interesting topic on the learning analytics and AI in smart learning environments that Professor Ogata shared with us, now it is the time to welcome some discussion and questions, please. Yeah, please, over there. There are two, so yeah, maybe three.
We have only 10 minutes before lunch, so please limit your question to one question per person, please. Thank you.
Hello. Thank you very much for your sharing. It's very interesting to know that a big corporation there. And my question is that on the data that you collect in institutional in Japan, I see that you collect into the LIS, right? Yeah. So what kind of data that have been collected and for analytic, right? Because there are many different kind of data and different kind of objective for learning analytic.
Yeah, thank you very much for the question. Yeah, actually, we collect data about the content, access to the content, ebook, and also learning management LMS, and also what is the student information system, SIS, and yeah, and also we store the syllabus or this kind of information. Yeah, but we don't currently record the video or because it's difficult to analyze, and also it's too big file size to record all that data. So currently we just record the text level. Because it's easy to handling and analyze the data. Thank you.
Thank you very much. We have a few more questions. Yeah, please.
Thank you, Professor Hiroaki, for your presentation. I have two questions. The first is about the book roll function, in which you reported higher reading time among the students upon using book roll. I wanted to ask, how do you define reading time? Because I was thinking in the book roll, they have this annotation, they can annotate and then they can do markers. So I was thinking if they interact with these tools, obviously the reading time will increase. So how do you define reading time in a book roll when you reported that data? And number two is you have this self-explanation tool that is AI generated, so students do not have to write why do X minus 2 and so on. Can you maybe share how do you establish the reliability of this self-explanation by AI because it's no longer done by the student, right? It is AI generated. So that's
thank you.
That's all.
Thank you very much for the question. Yeah, thank you very much. That's good questions. Yeah, actually, reading time is the we detect reading time. It's by using the page transition. Yeah. So the time difference between the previous page to the next page. Yeah, just simple. Yeah, time transition we are using. Yeah. So of course we define minimum time and also maximum time. Yeah. For example, minimum time is student just click and go to next page. So this is not reading. Yeah. So yeah. So we assume the the minimum time is the more than 3 minutes or so. Yeah. So and then the maximum time length is the about 10 minutes. Yeah. Yeah, we define this kind of information in the book, in the system. Yeah, otherwise, just some students go to the bedroom or when they are using the system. So this is not reading. So, but it's yeah, sometimes it's difficult to define this kind of time. Okay. And then another question. Okay, so about the self-explanation. Yeah. Yeah, so actually, yeah, it's not all, we don't request to write self-explanation for all the questions, all the exercises. So we ask only, how can I say, the questions which contains the multiple knowledge items. So we don't ask the student to write self-explanation to answer very simple questions like calculations or something like that. Yeah. Is it okay for your answer?
Okay, I think we are behind time. I'm so sorry. Please ask the professor on Padlet, and then we will ask him to please kindly attend to the question. I'm so sorry. Professor Ogata, you are very popular. There are many questions waiting for you to answer on the Padlet. So kindly please help us after this.
Yeah.
Ladies and gentlemen, it was a very delightful session indeed. So please join me to give him a big applause, please. Thank you. Thank you so much, Sensei. Okay, I have some housekeeping announcement, please.